Okay, so now let's look at some of the uses of ethanol. So for ethanol, definitely can be used to create your alcoholic drinks, like your beer, your wine. It can also be used as a solvent in your paints or varnish, perfumes, collagen, fuel for cars, generally mixed with petrol, though I don't think it's that effective lah for some, even for fuel for your cooking. Now comes the next one. What are carboxylic acid? So carboxylic acids, they tend to be a series of organic acids that has actually the carboxyl functional group, the COOH functional group. How it looks like is you have a double bond O, then your O and H. Okay. So with this carboxylic acid group, they would have the generic formula of CnH2n plus 1 COOH. So just now it was for alcohol is CnH2n plus 1 OH, but for this one there's an extra carbon. So just like your alkene, right, it must start off with a minimum of 2 carbon, okay, onwards. Though this HCOOH, right, they don't really, it's not as stable. That's why usually it starts with ethanoic acid. You rarely see methanoic acid. What are some of the properties? Carboxylic acids, right, are very soluble in water. This is similar to acids generally, and when they are able to dissolve in water, it behaves like an acid whereby it is able to release the H plus ions elsewhere. Though this is actually quite a weak acid, because when you throw it in water, right, some of the hydrogen ions are partially ionized outwards. So the strength is actually quite weak. Acid strength is different from concentration. Concentration is by numbers. Strength of acid is determined by how easy it releases the H plus ions. And then the boiling point would actually increase down the series of as the molecular size actually increase. Same explanation from the previous few one, whereby you have more intermolecular forces of attraction, therefore higher heat energy is required to overcome them. Now it comes to chemical properties. Because this behaves like an acid, what happens is mainly it will also undergo the acid-base reaction. Like metal plus acid, you'll get your salt and hydrogen gas. Carbonate plus acid, you will get your salt and carbon dioxide gas and water. Acid, when react with either your alkaline or base, you'll form your salt and water. Okay, and the only thing is because this is a weak acid, they tend to actually have a double arrow sign for this particular reaction. Reason being is because it's weak, you can actually move forward or backward reaction. Another situation that you'll see this is the manufacturing of ammonia. Okay, so carboxylic acids will have acidic property due to the hydrogen ions being produced. So like when you react with your reactive metal, you will actually form salt and hydrogen gas. And do take note, the hydrogen gas, how to test for it, it will actually pop. It will extinguish a lighted spleen with a pop sound. Okay. Then for carbonate, you will produce carbon dioxide and water. Passing it with lime water, you will actually form white precipitate and effervescence. With base, you will also be able to react with salt and water. This process is what we call a neutralization reaction. Okay. Carboxylic acid will also be able to react with your alcohol to form esters. Now, esters, what is esters? Esters actually have another different functional group. And that for esters, right, what will it do? It will have also other properties. Esters tend to give a very sweet smelling smell. Now we look at how are we able to produce the ethanoic acid. So number one is oxidation. Oxidation using your alcohol. So alcohol, when it undergoes oxidation, you will actually be able to form your ethanoic acid. And what is the color change? So for the oxidizing agent, right, potassium permanganate, they tend to actually they are actually purple in nature. After it has actually undergone oxidation already, Because as oxidizing agent, they oxidize others but they get themselves to be reduced. After it has been reduced, it will actually decolorize into a colorless solution. And so what happens is ethanol acts as a reducing agent. That means it reduces your potassium manganate. Your potassium manganate will oxidize your ethanol. Another thing is whenever you write your QA answers, right, you must always state from what color change to what color. You cannot say change to colorless. It has to be purple, the original color, changing it to colorless. Okay, the equation here, you would see that we use a bracket sign and an O to represent it to be from an oxidizing agent. Okay, very different from oxygen, O2. We can also oxidize it using atmospheric oxygen. That's why we put an O2 rather than a bracket, because this is pure oxygen. And what we actually need over here is actually your bacteria, because some bacteria, right, they were able to utilize the oxygen in the air to undergo oxidation. So sometimes when you put your alcoholic drinks around, after some time, why it turns sour is because it has been left exposed to the air. It has really undergone oxidation to form your carboxylic acid. Finally, esters. So esters, they are generally a sweet smelling liquid, and they tend to be insoluble in water. Why? Because they do not have the OH group, the hydroxide group. So what happens is this whole thing actually don't like water. They are hydrophobic. And being hydrophobic, they tend to be insoluble in water. The functional group is this. And how it looks like is actually a C double bond O. O attached to a C. So you could see that the OH, right, the OH group, right, is being removed to form the C. So when we look at the alcohol, which has a R, O, H, okay, where R is actually a very long carbon chain. Then you have your carboxylic acid, which is your R, C double bond O, O, H. Okay? What happens is when you have these two react together, you'll form your esters. And what happens is you would see that the H here, right, will actually be removed and it will actually combine with another OH to form water. Then the remaining one will actually form like this. So it's R, C double bond O, O formed with the R plus H2O. So the water, the OH here, will attach to the H here to form water, leaving the R attaching to the O. Okay? The whole thing. And this whole process is what we call esterification. So for esterification, this is how we do the steps, where we add the concentrated sulfuric acid. This acts as a catalyst to speed up the reaction of ethanoic acid reacting with ethanol to form this. Then you just heat it up to speed up the reaction. You pour the reaction mixture into this solution, knowing that ester is insoluble in water, so it tends to float. Okay, then the water and sulfuric acid tends to be below. It will still have sulfuric acid. Reason being is because sulfuric acid is just a catalyst, it's a spectator ion kind of thing. It doesn't participate in the reaction directly. So for this one, you could see that the hydroxide group from the OH group from the carboxylic acid is being removed, and it combines with the H group from the alcohol to form the water, whereas this particular portion is attached to this range here. Okay, so this is the whole process of esterification, and to help to speed up this process, we use concentrated H2SO4. So this one in exam, if they ask you whether water will be removed, the answer is yes lah. Water will be produced as a byproduct for the process esterification. Now, how do we name esters then? Esters is named mainly, right, by the two groups. One from the alcohol, one from the one from the carboxylic acid group. So the first name tends to actually give the name of the follow the name of the alcohol by stating the number of carbon atoms. So in this case, methyl would represent that it has one carbon atom, right, from the alcohol group. Then ethanoate means you have actually two of the carbon two of the carbon atoms from the carboxylic acid group. So you call it methyl ethanoate, where this particular name here would indicate that this is actually an ester. Okay, so we can see some of the combination here. It is quite straightforward for naming. So what are some use of ester? Because you see it has a very sweet smelling scent, right? So you can actually use to prepare perfumes, and then as artificial food flavors, right? It can also be used to give it a sweet kind of taste. So like sometimes your cotton candy, those kind of things, right? They also use esters. As solvents for cosmetics and even for glue or even in soap, those kind of body scent, body shop kind of soap, where it gives you that sweet smell, the aroma smell. Okay, and naturally occurring esters such as your animal fats and vegetable oils can be boiled with sodium hydroxide to form your soap. So these are some additional things which you know that it's just mainly there to create fragrance, sweet smelling fragrance. Okay, and that is all for this particular chapter for alcohol and carboxylic acids.